Visit Chandra's beautiful universe. Cygnus OB2. Most stars form in collections or groups called clusters or associations that include very massive stars. These giant stars send out large amounts of high-energy radiation, which can disrupt relatively fragile disks of dust and gas that are in the process of coalescing to form new planets. A team of astronomers used NASA's Chandra X-ray Observatory, along with ultraviolet, optical, and infrared data, to show where some of the most treacherous places in a star cluster may be, where planets' chances to form are diminished. The target of the observations was Cygnus OB2, which is the nearest large cluster of stars to our Sun, at a distance of about 4,600 light-years. Cygnus OB2 contains hundreds of massive stars as well as thousands of lower-mass stars. Astronomers used Chandra observations to map out the diffuse X-ray glow in between the stars and create a catalog of the young stars in the cluster. They then combined this catalog with others, using optical and infrared data, to create the best census of young stars yet in Cygnus OB2. The researchers found that there is a lot of high-energy radiation produced by stars and planets in these crowded stellar environments. They determined that the X-rays plus intense ultraviolet light in Cygnus OB2 would have a devastating impact on planetary disks and systems in the process of forming there. How would this happen? Planet-forming disks around stars naturally fade away over time. However, if these disks are close to massive stars that pump out lots of X-ray and ultraviolet radiation, this process of the disk destruction is accelerated. Instead of taking 5 or 10 million years, the disks around these giant stars are wiped out much sooner, possibly before planets have had time to form. The disks also disappear more quickly in regions where the stars are more closely packed together.